All right, hey everybody. Welcome back after kind of a long break there over Election Day and over the weekend. We're going to be getting into Unit 3 now. And Unit 3 is all about chemical bonding. And the first topic that we're going to be talking about with chemical bonding is ionic bonding, and specifically today, ion formation. Excuse me. So, your objective for today is for you to be able to predict the ionic charges that ions will adopt based on their number of valence electrons, okay? And you're going to be using patterns in the periodic table to predict these ionic charges. So, what is this all about? Well, the first big topic that we're going to be talking about in this unit is ionic bonding. It's going to take us a few days to sort of unpack everything. But basically, ionic bonding is one form of chemical bonding in which electrons are transferred from one atom to another. So what you end up with is oppositely charged ions. Okay, when an electron or multiple electrons move from one atom to another, you end up with oppositely charged atoms, which are called ions. These oppositely charged ions are bound together, right? Positive and negative, they attract, opposites attract. And so that's what makes up an ionic compound, are two oppositely charged ions stuck together in a new chemical compound. So what we're going to talk about today is how those ions form. Okay, and I'm not going to read all these rules to you right now. These are really just here to show you, in case you want to read this along at home, or if you're taking notes at home. Basically, the rule is, okay, in this last bullet point here, ions tend to form by losing or gaining electrons to achieve 8 valence electrons. Okay, so what that means, if I take a look at my periodic table here, okay, here are my numbers of valence electrons. We looked at this at the end of the last unit. Okay, so there's this pattern on the periodic table: 1, 2, 3, 4, 5, 6, 7, 8. Right, we have to skip this big section in the middle, right, the transition metals. But if we skip that big section in the middle, these numbers here on the tops of these columns tell you how many valence electrons each of these atoms has. Okay, and the rule is that atoms are going to gain or lose valence electrons to achieve 8 valence electrons. That's the number they're aiming for. Okay, that's energetically favorable for atoms, is to have 8 valence electrons. So I have a couple of examples that are on the next slide. I'm going to talk you through them right now. Okay, sodium has 1 valence electron. It turns out that if sodium loses 1 electron from its third energy level, that third ring, then there are actually 8 valence electrons underneath, okay? And so what's going to happen for all of these atoms here in this first column, they're going to all lose 1 valence electron to achieve 8 valence electrons. Seems kind of weird, but that's how it works, okay? And when sodium loses that 1 valence electron, what we end up with then is a positive charge of positive 1, okay? If you lose a negative electron, you end up with a positive charge. Okay? And the same thing is going to be true for these two columns here. Okay, so for example, aluminum has 3 valence electrons. It's going to lose those 3 electrons to end up with 8 valence electrons. And when it loses those 3 electrons, it's going to end up with a positive 3 charge. Okay, now kind of the opposite situation happens over here. If an element has, say, 7 valence electrons, like chlorine, for example, chlorine is going to gain an electron to get to 8 valence electrons, right? 7 plus 1 is equal to 8. The thing is, electrons are negatively charged, okay? So if chlorine gains an electron, its overall charge is going to be negative 1. Okay, that's a little bit backwards, right? It's a little bit counterintuitive, but it's something that you're going to have to get used to, okay? And then the same thing happens for these here, okay? So oxygen has 6 valence electrons. It's going to gain 2 negative electrons to get to 8. So it'll have a negative 2 charge, and then the same principle applies for these elements here with 5. Now there are some special cases here. If elements have 4 valence electrons, guess what? They don't really form ions. Okay, they tend to not lose or gain their electrons. They tend to share them instead, and that's a different type of bonding that we're going to talk about later in this unit. And then for these elements over here, the noble gas elements, they already have 8 valence electrons. They're not going to form ions either. Okay, so they're not going to gain or lose electrons either. So they tend to not form ions because they already have 8 valence electrons. Okay, so this labeling here is what you're going to want to use to answer a lot of the questions in the Canvas quiz for today. there is a version of this periodic table uploaded onto Canvas that I want you to use while you're working on the Canvas quiz. Let me show you where that is really quickly. Okay, so if I go to Canvas and I go into our Canvas course, up in the top module there is a link to a periodic table, and then there is a link to a labeled periodic table. This is the one that I want you guys to use. Okay, you can see here that we've got all of the labeling up here. The valence electrons are in blue, and the ionic charges are in black above that with the positive or negative symbols. Okay? All right. So let's go ahead and finish this up here. This next slide just goes over those two examples that I talked about, sodium and chlorine. Okay? Once again, in both these cases, the ions end up with 8 valence electrons, and while this is not always the case, this rule does hold true for most elements. Okay, so for our purposes, that rule is going to be able to be followed. So, when you're working on your Canvas quiz for today, you are going to need to use your periodic table to make use of the pattern that we saw. All right, and you can find that labeled version of the periodic table in Canvas. Make sure that you have this open while working on the assignment. It's going to be hard for you to answer the questions if you do not have that periodic table open so that you can use it as one of your resources. Okay? We'll do a question or two from the Canvas quiz together, but after this video, you'll be able to get started. Okay? Thanks for watching.